Welcome to chapter 1.5 of my Nabcep review. In this chapter, we'll be going over what a PV cell is, PV energy, um, most of the parts of chapter 1 that I left out of the first video, just a little housekeeping. In the first video, I noticed editing, I said the Nabcep doesn't care about efficiency, only fire protection. That's untrue. It's the NEC that cares about fire protection. The Nabcep does deal with efficiency. So, a solar cell, or a PV cell, or solar power. What is solar power? Solar power is power that comes from the sun. There's a few different kinds of solar power. There's CSP, um, there's PV cells, there's solar thermal, um, concentrated solar power. There's two types of this, actually. Anytime you concentrate the sun's rays via, a mirror or a lens, what you've done is concentrated the solar panel. There's two parts of this. There's a concentrated solar panel power that's also photovoltaic, and then there's a thermal one. Okay. In the concentrated solar panel that's photovoltaic, you'll use a lens. You'll concentrate it down on a very high efficiency solar cell, and you'll use that. That's a concentrated solar panel. In a thermal, you'll use basically a big mirror or a heliotrope. Use a big power tower and mirrors to concentrate the sun's rays onto that. You'll use the heat from heated up molten salt to run through turbines like you would, steam generator based on coal or natural gas. That's also solar power. Solar thermal in like a residential scope uses vacuum sealed glass tubes with cores that run usually hot water through them. Used to heat water, mostly for pools, residences. What we are dealing with though is PV, photovoltaic power, which this is what we're after. Photovoltaic is obviously photo, meaning light, and voltaic from volts. Let me erase. Just want to acknowledge that there's different types of solar panel out there. We're dealing with photovoltaic power. In order to get photovoltaic power, sun shines on a cell. That cell creates electricity. Without the heat that's generated in that cell does not help the cell produce electricity. There's several types of solar cells. There's a monocrystal. Most solar cells base material is made of silicon. Silicon is a semiconductor. It neither conducts it can either conduct or resist electricity, depending on the way you dope it. You can make solar cells out of other things, but most of them are made of silicon. Silicon can be treated in many ways, three of which are: it can be built into a monocrystalline cell. The way they do this is they supertreat silicon cells, they bring them into a very, very refined state, and they liquefy them. Then they dip a seed crystal into a vat, and they slowly turn that seed crystal until you have what's an ingot or a hog. And they have a weight, 200 pounds off the top of my head. That's not accurate. And then this ingot is one cell. It's one crystal. All the crystals are lined up. They go in exactly the same direction. It's a monocrystalline cell. What they do then is they either laser cut it or they saw it and smooth it out, and they use that to build cells. Another way to do that is to build a polycrystalline cell. A polycrystalline cell is a faster, cheaper, easier process where they get the same high quality silicone, they melt it down, and they pour it into a large block, and then they cut that block up. That doesn't produce the same like singular crystal throughout the entire block. That's why it's a polycrystalline cell. Polycrystalline cells are generally less efficient, however, not inefficient. Many of the cells that people put on their homes are polycrystalline cell. There's an amorphous silicone too. Okay. Amorphous silicone cells are actually pulled out in long ribbons. They're melted and they're rolled and pulled out into ribbons as they are melted, which means they don't have to be sawed, which means they can be flexible, which means they have a lot of properties that the monocrystalline and polycrystalline cells can't have. That being said, they are also less efficient. This type of cell are the ones you'd find on, backpacks. They're the ones that went on the new. They'll be in calculators. They'll be in small electronics. You can also get them for homes. When people talk about a solar power window, where the glass has actually been coated in a PV film, this is the kind of silicone they're talking about. Okay, silicone. Other ingredients in a PV cell. PV cells, most of the cells that you're going to deal with are made of silicone doped with boron and phosphorus. You can also get cells made of gallium arsenide. Write it down for you. Gallium arsenide. That's a much more efficient PV cell. They use them on space shuttles. They use them in that concentrated solar panel where they concentrated with the lens that we talked about earlier. They use a very efficient PV cell. You can also get a cadmium telluride cell. Also works. It's less efficient than the boron phosphorus cell that we're all becoming familiar with. Okay. All right. Now that we got our ingredients, I'm going to teach you how to build one of these things. All right. The thing you have to understand about a PV cell is that it creates energy from light. It doesn't create energy from heat. So heat actually reduces the amount of electricity, the amount of output that it can actually put out. So, how does it? Well, to understand that, you have to understand boron and phosphorus. And in the same way, you'd understand gallium arsenide or cadmium telluride. Phosphorus is an atom. It's atom number 15. So it looks like this. There's a little nucleus in the middle. There's a first ring, and I know that there's a physicist out there who's going to write a comment to me and say, that's not exactly how it is. I know it's not exactly how it is. But let me live my 12th grade science class fantasy and say that this is the way it is. Okay, phosphorus. Phosphorus has a little nucleus right here, and because it's number 15, it has 15 electrons running around it. The way the electron rings run up, the first one has 2, the second one 4, the next one 8, and the last one has 1 lonely electron. That means that phosphorus is more than willing to give up this electron to have a complete outside ring. It's just the way it goes. So this one has an extra electron. Electrons are negative. Phosphorus wants to make things negative. Okay. Boron. Boron's number 5. Has exactly the opposite problem. Boron has a nucleus right here, 2 in the first, 3 in the second, and in order to complete itself, it needs one more. So this is kind of missing a full outer electron shell. So and electrons are negative, and since it's kind of missing one, it wants to be positive. It's an electron hole. If these two could get together, they could work out okay. And all right. So understanding that. So when they build these silicone ingots, what they do is they dope them with phosphorus. Phosphorus is green. Okay? They pour them out into a nice big sheet. It's like 5/100ths of an inch thick. And it's just basically a big crystalline. You can't even see that. That's okay. It's a line. Then what they do is they expose it to phosphorus gas. And the phosphorus connects all over the outside of the silicon. And where the two meet, that's a positive being the boron and a negative being the phosphorus junction. Okay. After they do that, they have the positive covered with the phosphorus. They cut off the edges, and they basically sand off the bottom. So what you have is this two-layer cake where you have the boron doped silicon on the top and the phosphorus doped silicon on the bottom. And what wants to happen is electricity wants to flow. It can't. However, when the sun comes, this is the sun. A little smiley face like an environment. What it does is it gives enough energy to the atoms in the phosphorus to actually be knocked clear and go into the boron where they want to go, which creates a potential voltage. If you were to complete this circuit with a wire through a load of some kind, it's the first load. Electrons would flow. When the sun goes away, electrons don't flow anymore because they haven't actually been given the power. The power actually comes from the sun to give the electrons from the phosphorus enough energy to move through the boron and make a circuit happen. This process doesn't have anything to do with heat. It's important to understand that. And there's a lot of ways to measure it. That's actually the second part of this video. We're going to deal with measuring these things. Okay with that? Yeah. All right. Okay, about electricity. I don't know how much you know. Go over electricity really quick.